Hey guys, Dr. Betts here coming. Hey guys, Dr. Betts here coming. Hey guys, Dr. Betts here coming. Hey guys, Dr. Betts here coming with another fantastic chemistry video, and today we're going to talk about IUPAC or systematic naming. IUPAC, the International Union of Pure and Applied Chemistry. These guys make the rules, we follow them. Now, this is a standard method for everyone basically to learn how to name organic molecules. There was a time when things were just given random names, it seemed. We don't do that anymore. We have a systematic approach to naming things. Common names are kept, though, such as methane, ethane, butane, propane. These things are all kept. And it uses, and it's based on the idea of the longest chain of carbons. Okay? That will be your main chain, and everything else is branched off of that. Okay? So say you have 10 carbons in a row. That's a decane, and that's your longest chain. Everything else is a branch point off of it, and I'm going to show you how to do it. It's actually fairly simple. First rule, find the longest continuous or unbroken chain of carbon atoms and use that chain's name as the base name for the molecule. So it's going to be something, 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 something else, something else, something else, propane. So if the longest chain in your molecule is 3 carbons, let me get myself out of the way here. If the longest chain of carbons was 3, longest continuous chain was 3 carbons, you would name it this, that, the other thing, propane. That's the last thing you'll say. Number the longest chain beginning with the end of the chain nearest a substituent. Now, a substituent is nothing more than a group or atom that is not part of the longest chain. So, for example, if you have a long chain of carbons and there's a CH3 attached to it, that CH3 is a substituent. What do I mean by that? Well, it's substituting. Substituent implies substitution, correct? So substituting for hydrogen. So let's say you had something like this. CH3, CH2, CH3. And let's just say we had another molecule like this. Well, notice how in this carbon here, this is a propane, right? This is also a propane. The only difference is this one had 2 hydrogens. This one has 1 hydrogen and a substituent attached to it. Okay? So this is a methyl propane because there's something attached to it. There's a non-hydrogen attached to it. The hydrogen's been removed and replaced with something else. That's what's happened here. Okay? Let me back out of this to make more room here. Bear with me, please. My thing doesn't have an eraser, so I just have to hit back. There we go. Rule number 3. Name the groups attached to the longest chains as alkyl groups. Alkyl groups or alkane-derived groups. Alkyl basically means alkane-derived. Give the location of each alkyl group by the number of the main chain carbon from which it's attached. We'll get into that. Okay? It's a simple rule, but it doesn't really make sense when you read it. It only makes sense once you've seen it applied. And then write the alkyl groups in alphabetical order regardless of their position on the chain. So it doesn't matter. It's always alphabetical. And we'll see an example of this. All right. The main chain. Find the longest chain of consecutive carbons. So if we have this example here, notice we could count 1, 2, 3, 4, 5. We could have counted that way, right? That gives us 5 carbons. That would be a pentane. A lot of students want to count that way because it just seems easier. Yes, I know it seems easier. That's why I'm going to try to trick you. So don't just count the chain that's running from left to right or right to left. Look for the snake chain, but I call them snakes. Notice how there's a longer chain that runs around that way, right? Runs around this way. 1, 2, 3, 4, 5, 6. Oh, okay. So we have a longer chain. So that 5 doesn't cut it anymore. Now we're going to have 1, 2, 3, 4, 5, and 6. And yes, I know they're already printed there. Now, why did I start here for number 1? Why did I start here? Why not here? Why isn't this 1? Well, it's very simple. If this were 1, 1, 2, 3, 4. Carbon 4 is where my substituent is. Here's my substituent right here. That's my substituent. It's the thing branching off the main chain that is not hydrogen. Okay? So I need to give this substituent the lowest number. I need to give that substituent the lowest number. So if I start on this end, 1, 2, 3, there's my substituent. So this is going to be 3-methyl. If I start over here, 4, it would be 4-methyl. Okay? This one you don't want because it has a higher number, right? So let's get rid of it. Don't even worry about it. Don't even think about it. It's not there. You always start numbering the carbons from the terminal carbon closest to the substituent, to the first substituent, okay? Closest to the first substituent. So this would be a hexane for sure. It's actually 3-methyl hexane. All one word. 3-methyl hexane. Now the 3 tells the reader the position of this substituent on the longest chain. That's what it tells the reader. Okay? 3-methyl hexane. So I know I have a hexane. I have 6 carbons in a row, and there's a methyl on carbon 3. Everything else is hydrogen. Okay? Hydrogens are never indicated. They're always assumed. All right? And they're assumed in the name hexane. Now, what happens if you have a main chain? Sorry, you have the same number of carbons in a main chain, counting it 2 different ways. You always pick the main chain with the most substituents if there are 2 long chain carbon branches, or whatever you want to call them, that have the same number. Observe. 1, 2, 3, 4, 5, 6, 7. So there's 7 if I count it this way. 1, 2, 3, 4, 5, 6, 7. There's 7 if I count it this way. So I have 2 different ways to count to 7. You always pick the longest chain of carbons if all the other things are equal. If you get the same number 2 different ways, you pick the one that gives you the most substituents. Okay? This one has 4. This one has 3. So this is the correct way. Okay? This is the correct way. Because it gives you more detail, right? Telling someone more information is better than telling them less. Okay? So let's go ahead and name this. Why not, right? We're here. The terminal carbons are here and here. So let me circle those. This is a terminal carbon. That's a terminal carbon. So I can start numbering from here or from here. How do you figure it out? Well, you start with the carbon that's closest to the first substituent. Okay? 1, 2, 3 substituent. 1, 2 substituent. So you start here. So that's going to be carbon number 1. 2, 3, 4, 5, 6, and 7. Okay? This is carbon number 1. So, it has 7 carbons. So this is going to be a heptane. So it's going to be something, 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 heptane. Let's finish the naming. Notice on carbon 2, I have a methyl. And if you're wondering what I'm doing, I'm making a little table. On carbon number 3, this group here, CH2CH3, is called ethyl. Carbon 4, next one in the chain, has a methyl group. And let's continue. Carbon 5 also has a methyl group. And that's it. So these are all my substituents and the base hydrocarbon laid out. Now this is a very, very hard example. And that's okay. We can learn the hard ones, we can learn the easy ones, and you'll have to practice it on your own. And it will still be hard because without practice, you cannot be perfect. Let me name this for you, and then we'll do some easier examples. Why not, right? Oops. Well, that's okay. It's going to be 3-ethyl dash 2,4,5 dash trimethyl heptane. Three-ethyl. Let me draw that. Oops. Sorry about that, guys. Let me do that again for you. Ugh. It's going to be 3-ethyl dash 2, 4, 5 dash trimethyl heptane. Okay. Now I know that's a complicated example out of the gate. I get it. But here's a few things you want to take home with you. These are CH3s. CH3 is always called methyl. CH3, CH2, that's ethyl. CH3, CH2, CH2, that's propyl. You see what we're doing here? We're taking the base name of a hydrocarbon. So this is a CH3. It's got one carbon, so that's a methane. It's a methane. But it only has 3 hydrogens, so we're going to call it a methyl. So you're missing a hydrogen. Notice how they're basically derived, though, from the alkane names. 2 carbons, eth. 3 carbons, pro. When you're looking for the longest chain to give the base name, look to find all the different chains of that length. Often the longest chains will have the most substituents. Often the longest chain with the most substituents is not obvious. All right, moving on. So here are the base names for the substituents. And this one is not butane, it's pentane. There we go. All right, so we talked about methyl, ethyl, and propyl. We talked about these ones already. So here's butyl, and here's pentyl. Notice they're derived from the base name of the alkane. They're derived from the base name of the alkane. These will become second nature to you. We're going to use them so much. Don't worry. All right. Now, down here, or over here, I should say, it's a few important examples. This one, somewhat common. It's called isopropyl. You'll see it around. It's fairly common. You'll see it quite a bit in natural products and also in problems in the textbook. Isopropyl. Its skeletal formula looks like a V or a Y, however you want to describe it. Down on the 4 carbon ones, the most common one by far is tertiary butyl. This one here. Skeletal formula is usually like a cross, like that. So keep these two here in mind. You're going to see them from time to time. This one's by far the most common of all of them, but these two you'll see quite a bit. Oops, where's my drawing? Huh, my drawing got killed, I guess. All right, that's okay. I'll draw one for you. Sorry, let me just. Okay, guys, I'll pick it up here. All right, guys, here's one for you to try. Why don't you go ahead and see if you can name this hydrocarbon. Oops. All right, guys, here's one for you to try. Why don't you go ahead and try to name this hydrocarbon. All right, guys, here's one for you to try. Why don't you go ahead and try to name this hydrocarbon. I'll give you a few minutes. Pause the video if you really want to give it a try. All right, guys, we're back. Now the name. Let's find the longest continuous chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the same. Same. 1, 2, 3, 4, 5. Nope. 1, 2, 3, 4, 5, 6. Okay. So we can either number it from here or from here. Doesn't matter. You get the same name. So where do we start with carbon number 1? You always start at the carbon, the terminal carbon, with that is closest to the first substituent. So if I'm here, this is my terminal carbon, let's say. 1, 2. So my first substituent's 2 carbons away from is on carbon 2, right? 1, 2, 3. Okay, so it's obviously we're going to start from here. Let me get the numbers up. 1, 2, 3, 4, 5, 6. All right, so it's a hexane. And on carbon 2, we have a methyl. And on carbon 4, we have ethyl. Oops. All right, so carbon 4 has an ethyl. Now remember, it doesn't matter which one comes first in the numbers. It matters who comes first alphabetically, right? So this is going to be 4-ethyl -2-methyl hexane. 4-ethyl -2-methyl hexane. Now notice, numbers and letters are separated with dashes. Letter, number, dash. Has to be a dash between them. Number, letter, dash. Remember that, guys. All right, here's one for you to try. Now we're going to be doing multiple groups. Now, remember when I did the complicated example at the first one, I had the same group. I used the prefixes di and tri and tetra, and I put them all together, okay? Give this one a try on your own. It's a little tough for this level right now, but I think you guys can handle it. Give it a try. Pause the video. If you can't do it, don't worry. It's a tough one, and I'll show you how to do it, and then you'll be like, oh, okay, that's how you handle it. Not a problem. All right, guys? So go ahead and pause the video and give it a try. All right, welcome back. I know you guys really did well on this. I know you paused the video. I know you really did well. I have good faith in you. All right, 1, 2, 3, 4, 5, 6. Nope. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's our longest carbon chain right there. It's actually squared off for us. So this is a nonane. And we need to number the carbons from the terminal carbon closest to the first substituent. So here, if this is carbon 1 and that's carbon 2, so carbon 2 is my first substituent would be if I number from here. If I number from here, it's carbon 1, carbon 2, carbon 3, and carbon 4 is where I find the first substituent. So obviously you don't number from here, you number from here. 1, 2, 3, 4, 5. Remember, these are just carbon numbers, right? 6, 7, 8, 9, 10. Did I miscount? Oh, it's a decane. Never mind. I was never here. It's actually a decane. Sorry about that, guys. All right. See how easy it is to make mistakes in these things? Now let's put it all together. So it's 2-methyl, 5-methyl, 7-methyl. So we put everything together. It'll be 2, 5. Now, numbers are separated via commas. Numbers have to be separated with commas. So it should be 2, 5, comma 7 dash. Okay, because now there's a letter coming up. Tri. Because there's 3 of them. 1, 2, 3. Methyl decane. Two, 7, 2, 5, 7 dash trimethyl decane. That's how you name that one. Woo, lucky. All right. Give the structures for 4 isopropyl octane and 5 T-butyl decane. Just so we're on the same page. Isopropyl, remember? Let me draw that a little better for you. That's pretty messy. Isopropyl. T-butyl. Okay, that's what those look like. So I'll help you a little bit there. We'll go ahead and draw these structures. This is not naming. This is taking a name and drawing a structure. It's a little bit easier. That's why I didn't really talk about it. Just gave you a problem. It's a little bit easier. Pause the video. Make it happen. All right. You're back. I'm sure you all got it right. Let's do the first one. This one here. So it's an octane. So let's just draw 8 carbons in a chain. And there's 8. And on carbon 4, 1, 2, 3, 4, there is a isopropyl. There you go. And the other one, decane. There you go. And on carbon 5, 1, 2, 3, 4, 5, there is a T-butyl right there. That's how you do it. All right, so that's a quick intro to IUPAC naming of alkanes, and I'm going to leave it there. Now, IUPAC naming is complicated. It's scary when you first start it, but it actually is not that bad, guys. So don't be too intimidated by it. Please don't be intimidated by it. It's not that hard. All right, so now I'm going to leave the video here. We're going to come back. We're going to talk about methane representations and how to draw things in 3 dimensions. It's going to be fun. It's going to be epic. I can't wait to talk about it. But for now, I want to wish you all good luck and good chemistry. We'll see you soon.